Hi everyone. Today we're going to study definition, terms, and common difference of arithmetic sequences. First, let us define arithmetic sequence. An arithmetic sequence is a sequence that has the property that the difference between any two consecutive terms is a constant. This constant is called the common difference. If a sub 1 is the first term of an arithmetic sequence and d is the common difference, the sequence will be like this. A sub n equals, the elements are a sub 1 as the first term. The second term is a sub 1 plus d. The third term is a sub 1 plus 2d. The fourth term is a sub 1 plus 3d. So on and so forth. We may also write arithmetic sequence in simpler form like this. The first term is a sub 1. The second term is a sub 2. Third term is a sub 3. Fourth term is a sub 4. So on and so forth. Let's have an example of an arithmetic sequence. First term is 1. Second term is 4. Third term is 7. Fourth term is 10. So on and so forth. Or we may write a sub 1 is 1, a sub 2 is 4, a sub 3 is 7, a sub 4 is 10. For the common difference, we may compute this using the formula a sub n minus a sub n minus 1. This is difference of any two consecutive terms. So it's like a sub 2 minus a sub 1, or a sub 3 minus a sub 2, or it can be a sub 4 minus a sub 3, and the difference must be common. As an example, we may show that a sub 4 minus a sub 3, and this is 10 minus 7, and the answer is 3. The common difference helps us also to provide the next term after 10, and that is a sub 5, which is 10 plus the common difference 3 is equal to 13. So on and so forth. So we say, once a sub n is known, next term is derived by adding d, the common difference, to it. Let's have more sample problems. Sample problem 1. Write the first 6 terms of the arithmetic sequence with a sub 1 equals 3. This is the first term. And common difference d equals 2. Let us write the general form, and it is written here. Since we need 6 terms, we may write a sub 1, a sub 2, up to a sub 6. In the problem, a sub 1 is already given, which is 3. So we may substitute this value for the a sub 1 in our sequence. Next, we know that next term is derived by adding d to the previous term. So the a sub 2 is equal to a sub 1 plus d, and that is 3, that is the first term, plus 2, the common difference. and the answer is 5. And this number 5, we will substitute to a sub 2 in our sequence here. So for a sub 3, that is equal to a sub 2 plus d, and a sub 4 equals a sub 3 plus d, a sub 5 equals a sub 4 plus d, and a sub 6 equals a sub 5 plus d. So we have this a sub 3 means the 5, which is a sub 2 plus d, is equal to 7. And for a sub 4, that is 7 plus 2, which is 9. A sub 5 is 9 plus 2, which is 11. A sub 6 is 11 plus 2 and equals 13. So these 4 values we will substitute in our sequence here. So the first 6 terms of the arithmetic sequence are 3, 5, 7, 9, 11, and 13. This is our final answer. Let us have example 2. Write the first 5 terms of the arithmetic sequence with a sub 1 equals 17 and d equals negative 3. We need 5 terms, so we write here the general form of arithmetic sequence with 5 terms. The first term is already given as 17, so we will substitute this value in our sequence. For a sub 2, that is equal to the first term plus the common difference d, and that is 17 plus negative 3, which is equal to 14. And this value we will substitute to a sub 2 in the sequence. For a sub 3, a sub 4, and a sub 5, we will compute by simply adding the common difference to the previous term, respectively. So a sub 3 is 14 plus negative 3, that will give me 11. For a sub 4, that is now 11 plus negative 3 equals 8. A sub 5 is now 8 plus negative 3, which is equal to 5. So these values here we will substitute to our sequence. So the first 5 terms of the arithmetic sequence with a sub 1 equals 17 and common difference equals negative 3 are 17, 14, 11, 8, and 5. This is our final answer. Let us have sample problem 3. Is each sequence arithmetic? If so, find a common difference. We have problems A and B here. Let's begin with the sequence A. We can see here that the first term is 1, second term is 2, third term is 4, fourth term is 8, fifth term is 16. In order for us to prove that this is an arithmetic sequence, the difference of 2 consecutive terms must be common. So it means a sub 2 minus a sub 1 is equal to 2 minus 1 equals 1. A sub 3 minus a sub 2 equals 4 minus 2, and that is equal to 2. A sub 4 minus a sub 3 equals 8 minus 4 equals 4. A sub 5 minus a sub 4 equals 16 minus 8 equals 8. We can see that the difference is not common for any 2 consecutive terms. So we can conclude that the sequence A is not arithmetic. We will write our answer opposite sequence A. Let us go to sequence B. The first term is -3, second is 1, third term is 5, fourth is 9, fifth term is 13. Again, we will compute for D, and it must be common. A sub 2 minus A sub 1 equals 1 minus -3, and that is equal to 4. A sub 3 minus A sub 2 equals 5 minus 1 equals 4. A sub 4 minus A sub 3 equals 9 minus 5 equals 4. A sub 5 minus A sub 4 equals 13 minus 9 equals 4. We can see that the difference is common and equal to 4. So sequence B is arithmetic. Let us write our answer opposite B, and that is arithmetic, and the common difference is 4. Hi everyone. Today we're going to study general term of an arithmetic sequence. The formula for general term of an arithmetic sequence is here. A sub n equals A sub 1 plus the quantity n minus 1 times D. Take note, the subscript n here is the same with the variable n in here, where the A sub n equals general term, A sub 1 is the first term, the n is the number of terms, and D is common difference. Let us have example 1. Find the 10th term of an arithmetic sequence with A sub 1 equals 4 and D equals 5. The formula is given here. Let us substitute the values. The A sub n means A sub 10. We are looking for the 10th term. So this is A sub 10 equals, the A sub 1 is 4 plus the quantity n is now 10 minus 1, that is a constant, times D, which is 5. Let us simplify further. So 10 minus 1 gives 9. So we have now A sub 10 equals 4 plus 9 times 5. The product of 9 and 5 is 45. Then we will get the sum of 4 and 45, and that is 49. So the 10th term of this arithmetic sequence is 49. This is our final answer. Example 2. Find A sub 21 of an arithmetic sequence 0, 4, 8, 12, 16. The general term formula is written here, and let us write the given and the required values. A sub 21 is the required value. Our A sub 1, the first term, we can get from the given sequence. And the D, the common difference, is not readily given but can be computed. We can take any two consecutive terms and then we will subtract. So we have 4 minus 0, that is 4. And that is a common difference. Or we may get the difference of 8 and 4, which is 4 also. 12 minus 8 is also 4. 16 minus 12 is also 4. So we are sure that this is an arithmetic sequence with a common difference of 4. Solving for a sub 21 now, we are using this general term formula. Let us substitute the values. So we have here a sub 21 equals the first term, and that is 0, plus the quantity 21 minus 1 times the common difference d, and that is 4. Simplifying further, so the 0 here can be deleted. The 21 minus 1 is 20, then multiplied by the 4. So our a sub 21 equals the product of 20 and 4, and that is 80. This is our final answer. Let us have example 3. In an arithmetic sequence, a sub 1 equals 8 and a sub 4 equals 14. Find a sub 5. Again, we will write here our general term formula. The required value is a sub 5. Using our general term formula with regard to our a sub 5, this is equal to a sub 5 equals 8, and that is the first term, plus the quantity, the n is also 5, and then minus 1, times d. There is no common difference given in the problem. So we need to get this value d by using the given value, which is a sub 4 equals 14. Using our general term formula with regard to a sub 4, we can write a sub 4 equals a sub 1 plus the quantity 4 minus 1 times d. This a sub 4 is equal to 14, and a sub 1 equals 8. Substituting these values, we have 14 equals 8 plus 4 minus 1 times d. Let us simplify this equation. This number 8 we will transpose on the other side. The sign will be changed. It will be negative. And then this 4 minus 1 becomes 3. So we have here 14 minus 8 equals 3 times d. This 14 minus 8 gives 6 equals 3d. And we want to isolate d. We will divide this equation by the coefficient of d, which is 3. So this 6 divided by 3 will be 2, and 3d divided by 3 is only d. So we can write d equals 2. This is the common difference, and this value is what we need in here. So substituting that value, we will be able now to get a sub 5. Simplifying further, this 5 minus 1 is now 4. So our a sub 5 is equal to 8 plus the product of 4 and 2. So we have 4 times 2 is 8, and then 8 plus 8 will give us 16. The a sub 5 is 16. Just a quick check. Let us write the terms of the given sequence. Knowing that our d, the common difference, is 2, we may start with the first term 8 as given in the problem. Then 8 plus d, that is equal to 10. This is the second term. 10 plus 2 is 12. 12 plus 2 is 14. This is the fourth term that is given in the problem. And the fifth term, 14 plus 2 is 16. So this a sub 5 equals 16 is our final answer. Let us have example 4. Find the first term, common difference, and a sub 20 of an arithmetic sequence if a sub 6 equals 12 and a sub 14 equals 28. The general term formula is here. Then let us write what is required in the problem. The first is the a sub 1, that is the first term. Next is the d, the common difference, and a sub 20, the 20th term. We can solve this a sub 20 once we know the first term and the common difference as a requirement in the general term formula. So let us solve for this a sub 1 and d using the data in the problem. Let's begin with a sub 6 equals 12. Let us write this a sub 6 with regard to our general term formula. So this is a sub 6 equals a sub 1 plus the quantity 6 minus 1 times d. Let us substitute the value of a sub 6 as 12. So this is now 12 equals a sub 1 plus this 6 minus 1 is 5 times d. So this is 5d. The second data is a sub 14 equals 28. Also, let us write this a sub 14 with regard to our general term formula. So a sub 14 equals a sub 1 plus the quantity 14 minus 1 times d. Let us substitute the value 28 for this a sub 14. So we have now 28 equals a sub 1 plus this 14 minus 1 is 13. Then the d is attached. So 13d. Let us regard this 12 equals a sub 1 plus 5d as equation 1 and 28 equals a sub 1 plus 13d as equation 2. Let us put them together because we're going to solve for a sub 1 and the d. Let us subtract these two equations so that the a sub 1 will be cancelled. When we subtract, we will have this 12 minus 28 is negative 16. The a sub 1 here and the a sub 1 here is cancelled out. And the 5d minus 13d gives negative 8d. We want to solve for d. We will divide this equation by the coefficient of d, which is negative 8. So this negative 16 divided by negative 8 is positive 2. And this negative 8d divided by negative 8, then this negative 8 will cancel out. Only d comes down. So we can write d equals 2. So this is our common difference. Let us copy this value in here. So we are done with our d. Let us now solve for a sub 1. Let us use equation 1. We will substitute the value of d here. So we have now 12 equals a sub 1 plus 5 times 2. Simplifying further, this 5 times 2 is 10. And we want to get the value of a sub 1. We will transpose this positive 10 to the left side. So it becomes negative. So we have now 12 minus 10 equals the a sub 1. And this 12 minus 10 is 2. So we can write a sub 1 equals 2. Let us copy this value opposite a sub 1 on this part. So we are now ready to solve for a sub 20. using our general term formula, the a sub 20 equals 2, that is the first term, plus the quantity 20 minus 1 times d, which is also 2. Then simplifying further, 20 minus 1 gives 19. So we have a sub 20 equals 2 plus the product of 19 and 2. So 19 times 2 is 38, and then 38 plus 2 is 40. We are going to copy this value opposite a sub 20 in here. So now we are complete with the required values of the problem. A sub 1 is 2, the first term. The common difference is 2 also. And a sub 20 is 40. This is our final answer. Hi everyone. Today we're going to study sum of finite arithmetic series. Let us define arithmetic series. If a sub 1, a sub 2, a sub 3, up to the last term a sub n is a finite arithmetic sequence, then a sub 1 plus a sub 2 plus a sub 3 plus all the terms up to the last term a sub n is called an arithmetic series and denoted by S sub n. This is the general form of arithmetic series. Let's have examples. Here we have S sub 2 equals a sub 1 plus a sub 2. It means we are going to take the sum of the first two terms. Second example, S sub 5. It means we are going to take the sum of the first 5 terms of the arithmetic sequence. So you see, this is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. Example 3 is S sub 10. So let us take the sum of the first 10 terms of the arithmetic sequence. So here we have a sub 1 plus a sub 2 plus a sub 3 up to a sub 10. Let's go now to the sum formulas for finite arithmetic series. We have the first formula, and it's written as S sub n equals the fraction n over 2 times the quantity 2 times a sub 1 plus this binomial n minus 1 and multiplied to d. We are going to use this formula if the given are the first term, that is a sub 1, the common difference, that is d, and the number of terms, and that is n. We will use here and also here. There is also the subscript of the s. There is a second formula, and it is S sub n equals the fraction n over 2 multiplied by the sum of a sub 1 and a sub n. We're going to use this formula if the given are the first term, that is a sub 1, the last term, the a sub n, and the number of terms, and that is the n that is used as numerator on the fraction and the subscript of the s. Let us have example 1. Find the sum of the first 20 terms of the arithmetic sequence 2, 7, 12, 17, so on and so forth. Let us list the required and given data. S sub 20 is the symbol for the sum of the first 20 terms. A sub 1, the first term, is equal to 2. The common difference is not directly given in the problem, but we can compute by simply subtracting two consecutive terms like this. 7 minus 2 is 5. Or 12 minus 7, that is also 5. Or 17 minus 12 is also 5. And n equals 20 as specified in the problem as first 20 terms. Let us use the first formula. S sub n equals the fraction n over 2 times 2a sub 1 plus the quantity n minus 1 times d. Let us substitute the values respectively. The n is now 20. The a sub 1, the first term, is now 2. The n here is also 20. And the common difference is 5. Simplifying further, we can have this 20 over 2 is 10. 2 times 2 is 4. 20 minus 1 is 19 times 5. And then we will multiply 19 and 5. It becomes 95. We will take the sum of 4 and 95. We will get 99. Still, the number 10 is copied down here, and the S sub 20 is here. So 10 times 99 is 990. It means the sum of the first 20 terms of the given arithmetic sequence is 990. This is our final answer. Let us have example 2. Find the sum of all the odd numbers between 51 and 99 inclusive. Let us list the required and given data. The first is S sub n. This is the sum of all the odd numbers as required in the problem. The first term is 51. The a sub n, this is the last term, equals 99. The n, the number of terms, is not specified in the problem. So still this is a question mark. We can use the second formula because in here the given is the first term and the last term. However, we don't have the n. First, let us solve for this n. Remember, we have the general term formula that is like this. A sub n equals a sub 1 plus the quantity n minus 1 multiplied to d. Let us substitute the values. The 99 is the last term, so we will put here equals a sub 1 is the first term, that is 51, plus the quantity n minus 1 will be same, and d is 2. Remember, the interval between odd numbers is 2. So that is the common difference. Let us simplify this equation, then solve for n. So on the next line, we will multiply this number 2 to n and to negative 1. So we have 2 times n is 2n. 2 times negative 1 is negative 2. And then this 51 and the negative 2 can be combined together as 49. So we just copy this positive 2n and the 99 on the left side. Let us isolate the 2n. This 49 must be transposed on the left side. So from positive, it becomes negative. So 99 minus 49 equals 2n. So the difference is 50 and this is equal to 2n. Let us simplify by dividing this equation by the coefficient of n, which is 2. So this 50 divided by 2 is 25. 2n divided by 2 is n. So we can write n equals 25. This is the number of terms, and this value we will copy opposite the n on this side. Now, we can now solve for our s sub n. By the way, this n here as 25, we can now change the s with the subscript 25. Also, the a sub n becomes a sub 25, and this 99 is the 25th term of the sequence. Let's go now to solve for s sub 25. Substituting the corresponding values, the n is now 25, a sub 1 is 51, the a sub n or the a sub 25 is 99. Then let us simplify further. This 51 plus 99 is 150. And then let us cancel this 150 and the denominator 2. We will get 75 multiplied to 25. And the product is 1875. This is our s sub 25. This is our final answer. Let us have example 3. Find the a sub n, a sub 10, and s sub 10 of the arithmetic sequence 3, 7, 11, 15, so on and so forth. Let us list the required and given data. The first is a sub n. This is the general nth term. Next is a sub 10. It means the 10th term. Next, s sub 10. This is the sum of the first 10 terms. Given is a sub 1. That is the first term, which is 3. And the d, which is equal to 4. Although it is not readily given in the problem. But we can compute by subtracting two consecutive terms, like 7 minus 3 is 4, or 11 minus 7 is also 4. 15 minus 11 is also 4. So let us start by solving a sub n. Let us substitute the first term and the d, the common difference. So we have a sub n equals 3, the first term, plus the quantity n minus 1 will be same, multiplied to d, which is 4. Let us simplify further. This number 4 will be distributed to n and to negative 1. So 4 times n is 4n. 4 times negative 1 is negative 4. Then let us combine this positive 3 and negative 4. So we have negative 1. So our a sub n equals 4n minus 1. So this is the value of a sub n as a function of n. Let us copy this value opposite a sub n in here. And then let us clear the board and solve for a sub 10, the 10th term. Let us use our general term formula. So that is a sub 10 equals a sub 1, the first term is 3, plus n is 10 minus 1, multiplied to d, which is 4, the common difference. Simplifying further, this 10 minus 1 gives 9, and let us multiply 9 by 4 is 36. Then the sum of 3 and 36 is 39. This is our a sub 10, the 10th term. Let us copy this value opposite a sub 10 in here. Then let us clear the board and solve now for s sub 10, the sum of the first 10 terms. Let us use the second formula, a simpler one, because we have the first term and the last term as defined. We can also use the first formula here. However, the second formula is much easier to use. So s sub 10 equals n over 2 is now 10 over 2 multiplied by a sub 1, the first term is now 3, plus a sub n, or this is a sub 10 equals 39. Simplifying further, 3 plus 39 is 42, and then 10 over 2 is 5. Let us multiply 5 times 42. The answer is 210. This is the sum of the first 10 terms of this arithmetic sequence. Let us copy this value opposite s sub 10 on this side. So we are done with our example 3. These are the final answers. I hope you learned something from this video. See you again next time.